What if I told you that the most complex and mysterious object in the known universe is not out there, nestled among the stars and galaxies? What if it's closer, much closer? In fact, what if it's right behind your eyes, tucked safely inside your skull? This 3-pound lump of grayish wrinkled tissue, your brain, is an astonishing cosmos unto itself. It holds every memory you've ever made, every dream you've ever had, and every person you've ever loved. It is the engine of your consciousness, the architect of your reality. And yet, for all its intimacy, it remains a profound enigma, a universe we have only just begun to explore. Consider this for a moment. With your brain, you can ponder the vastness of space. You can contemplate the beginning of time and the fate of stars. You can compose a symphony, write a poem, or solve a mathematical equation that describes the very laws of nature. Think of your body as a grand orchestra. Think of your body as a grand orchestra. You have the percussion section of the heart, beating a steady rhythm, the woodwinds of the lungs, and the string section of the muscles, poised for graceful movement. Every part has a role, a specific function needed for the symphony of life. But who holds the baton? That conductor is your brain. It is the undisputed maestro, the central command center from which all orders flow. From its protected perch atop your spinal cord, the brain acts as the ultimate CEO of you Inc. It processes an unceasing flood of data from your senses, the light entering your eyes, the sound waves vibrating in your ears, and the texture of the keyboard beneath your fingertips. It's a master interpreter, taking raw, meaningless signals and weaving them into a coherent story, your reality. At the same time, it sends out a constant stream of commands. It tells your legs to walk, your hands to grasp, and your vocal cords to form words, all at speeds that make supercomputers envious. But the brain's role extends far beyond mechanics. It's the seat of your personality, your emotions, your very essence. How does this master conductor actually work its magic? The secret lies in its fundamental building blocks, specialized cells called neurons. Imagine a forest, vast and dense, with 100 billion trees. Each tree is a single neuron. Each neuron is like a tiny biological wire with long, spindly branches called dendrites that act like antennas receiving signals from neighbors. When a neuron fires, it sends a brief electrical pulse, an action potential, racing down its axon like a tiny bolt of lightning. Neurons don't touch. To cross the microscopic synapse, the electrical signal becomes chemical. Neurotransmitters released, floating across the gap and triggering the next neuron. A spark of electricity, a puff of chemicals, happens billions of times every second inside your head. A relentless, high-speed relay race of information. A simple thought, remembering breakfast, can involve millions of neurons firing in coordinated patterns. A complex action like riding a bicycle engages a symphony of pathways, all firing in harmony. Every skill you learn, every memory you form, physically changes connections, strengthening some synapses, weakening others. You are sculpting your brain with every experience. It's a cosmic game of telephone at unbelievable speed and scale. A signal starts in the visual cortex, whispers across regions, interprets shapes as letters, letters as words, words as ideas, the loom upon which consciousness is woven. We've seen the brain's hardware, neurons, synapses, electrical signals. We understand the mechanics, the nuts and bolts of how information travels. But understanding how that firing creates the subjective experience of being you is something else entirely. How does a storm of electrical activity produce the feeling of seeing the color red, the sound of a favorite song, or the complex emotion of nostalgia? This is the so-called hard problem of consciousness, the ghost in the machine. Scientists can watch your brain light up in an fMRI when you look at a photo of someone you love. They can pinpoint regions, the amygdala for emotion, the fusiform for faces, and trace pathways and measure the chemical soup. Consciousness seems to be emergent, arising from complexity yet not located in any single part. This mystery deepens when we ask where exactly you are located. Your sense of self seems to be a story your brain constructs, a brilliant illusion. But if self is a story, who is the listener? We are like explorers on a new world, able to map the land but still puzzled by its weather. Consciousness is the brain's weather. We can see its effects and correlates, but not the fundamental process that creates experience. Sometimes, the greatest insights come when something breaks. In neuroscience, few stories illustrate this better than Phineas Gage. Back in 1848, Gage was a railroad foreman packing a hole with gunpowder and tamping it down with a long iron rod. The powder ignited prematurely. The tamping iron shot through his skull. It entered below his left cheekbone, tore through the frontal lobes and exited the top of his skull, yet miraculously he survived. He was conscious, talking, taken by oxcart to a doctor. His memory and intelligence seemed intact, but the man who returned was no longer the same. Once reliable and mild-mannered, he became impulsive, profane, erratic. Friends said he was no longer Gage. He couldn't stick to plans or social conventions. The tamping iron had destroyed much of his frontal lobes, a region now known to be critical for planning, decision-making, and social behavior. Gage's misfortune provided the first strong evidence that specific parts of the brain tie to specific aspects of personality. It shifted our view of the brain from a unified organ to a collection of specialized modules working together. Phineas Gage became an unwilling pioneer in exploring the human mind. For centuries, our view of the living brain was like looking at a locked black box. All that began to change in the late 20th century with a revolution in technology. One of our most powerful tools is fMRI. It doesn't read thoughts, but it tracks blood flow. When a region needs oxygen, fMRI sees the rush. By giving tasks, reading, listening, solving problems, we can map which regions work together. EEG lets us listen to the brain's electrical chatter with millisecond precision. We trade spatial detail for time. Together, these tools give complementary views, where activity occurs, and when. These tools converge in projects like the Human Connectomy Project, an ambitious wiring diagram of the brain. Each year the maps become more detailed, revealing connections we never knew existed. It's like seeing city lights turn on block by block, drawing coastlines and tracing neural rivers. For the first time in history, we are charting the cosmos within. We are living in a golden age of neuroscience. More has been learned in decades than in all prior history. The pace of discovery is accelerating, and the frontiers ahead are vast. For a long time, scientists thought the adult brain was fixed and unchanging. You had the brain you were given, and that was that. But modern neuroscience overturned that. The brain is dynamic, malleable, and constantly reorganizing. This ability is called neuroplasticity. Your brain changes physically every day in response to experience. When you learn a skill, you aren't just memorizing movements. You are rewiring your brain. Pathways become stronger, faster, more efficient. The brain map devoted to your fingertips can expand with practice. Neuroplasticity has profound implications for recovery. With targeted therapy, the brain can recruit other regions to take over lost functions. It creates new pathways, builds connections, finds clever workarounds. It's a testament to resilience. We are not passive victims of our wiring, we can actively shape it. Through focused attention, practice, and learning, we can change our minds. Every choice, every thought, every action is a tap of the chisel shaping who you are becoming. The brain isn't just something you have, it's something you do. Despite progress, much of the brain map remains blank. For every answer, a dozen new questions appear. The territories we haven't explored are vast and hold some of the deepest mysteries in science. One of the greatest puzzles is memory. We know it's stored as changes in synaptic strength, long-term potentiation, but how does that translate to recalling your 10th birthday? The sights, the sounds, the taste of cake, how are they retrieved from a sea of trillions of connections? Then there's sleep. We spend a third of our lives doing it. It's critical for memory consolidation, clearing metabolic waste and cellular repair. But why must we enter near total paralysis? What is the purpose of dreaming? Random firing or a deeper function? We still ask, what is the biological basis of intelligence? How do disorders like schizophrenia or autism arise from wiring or chemistry? And how do we halt neurodegenerative diseases that rob people of mind and identity? These are the challenges for the next generation. Frontiers we must cross to understand our inner universe. What will we learn when we can map the brain neuron by neuron, decipher the code of memory, or understand the origin of a single thought? Will we build a truly conscious machine, or is there something inimitable about biological wetware? Our journey into the 3-pound cosmos inside our skulls leaves us with wonder and humility. We traveled from the mechanics of a single neuron to the grand mysteries of consciousness and memory. The brain is not a simple computer but a living, ever-changing universe of its own. It builds our reality, shapes identity, and gives us the tools to question its own existence. The quest to understand the brain is a story of human curiosity. From tragic accidents to science fiction technologies, each discovery, each new map deepens our appreciation for this biological machine. We live in a golden age of neuroscience. The pace of discovery is only accelerating, but ultimately, our exploration has just begun. We are standing on the shore of a vast, uncharted ocean. What will we find when we can map the brain in real time, neuron by neuron? Hidden in the silent, intricate dance of our neurons, what astonishing secret will the brain reveal to us next?